Welcome to a read along with Dr. Powell in the book Discrete Perspectives in Mathematics. This is subsection 225, conjunctive and disjunctive normal form of a Boolean algebraic expression. So, if we have a Boolean algebraic expression, something that you can write in terms of ands and ors with a's and b's and other things like that, um, it'd be nice if the form is like this: something union something union something. So we kind of just see it as just a unions of a lot of things, or something intersect something else, intersect something different, and so forth. In particular, it'd be nice if these somethings, so in this particular case, like here, this something here, union, if this something was just, a lot of things added together, like this. See, there's something, and there's an or something, and there's or, and there's something. And what's in here is they're all anded together in there. Similarly, we could have something like this with an and then we can have ors in the middle. In our two examples that we showed, actually, the we were considering things in these forms. This allows the sandwiching process to work a little better when you can kind of think about things in this form, because here, then you think about unioning something on, and you can kind of tell, okay, I'm unioning something on, what is a subset of it, and then just cross it out because it's also union on. Or here, for if you're intersecting something on, then you can see, okay, well, it is a subset of what? And it's easy to see that if you have unions in the middle here. So these two forms are very actually quite useful if we can rewrite an expression in one of these forms. And we'll discuss how to do that later in this particular section. All right, but let's keep on going down and see kind of how we can convert between these forms. Are they convertible? Well, remember that that union distributes over intersection. Intersection distributes over union, or and over or over and. It's just nice distributive property. We can distribute both ways. So in distributing, like for instance, if you have something of this form, you can take this and distribute it to each parts, and the following, where this distributes over with this to those. So let's see how that works. Yes. So that distributes with an or to that, an or to that. And you have these, and then you have these anded on. And then you can, okay, and then you can likewise take this and distribute it inward, like that. Okay, distribute that inward like that to each particular part. And then, okay, so you have ands, and then by associativity, you can, okay, see, these are ands in here, and ands in there, and ands in there. So that's just a lot of ands, and then you have ors. Hey, we've just successfully rewritten it from one form to the other. This would be conjunctive normal form. Conjunction, think of it as a conjunction as kind of like an and, if you will. So and in between. Disjunction, think of that as an or in between. Dis for or and con for and, or however you want to think about that. But so this right here would be conjunctive normal form, and it began in disjunctive normal form. So we can translate something from disjunctive normal form to conjunctive normal form just simply by using distributive properties of ands and ors. Now, of course, this can probably be simpler, written in a simpler way. B union with B is just B itself. And that, in fact, I wrote that right here. It can be simplified, and it should be. So you can look through that, and encourage you to try that out and see if you can simplify it. All right. So now, how can we use this disjunctive and conjunctive normal form to help us to swallow a little bit? Or sandwich swallow. That sounds kind of funny, but to do this this technique, which I call sandwich swallowing of expressions. All right. So um, okay, so let's take a look at that. I kind of give some rules of thumb for if something's like in disjunctive normal form. Like, what do you pick? Like, which sub-expression do you choose to want to sandwich between like one, like it and one, or something like that? Well, if you're in disjunctive normal form, the usual technique is to try to find something that you want to merge to one, and that if you make it merge to one, it'll make the whole thing merge to one. And usually, the way you do that is you try to pick a sub-expression of one of the islands here between the oars. So here, like in here, notice that this is a sub-expression, and it works best if the sub-expression actually repeats itself. It doesn't have to repeat itself, but if it does, it's like, oh yeah, let's pick that one. Like in this case, maybe that would be a good choice. Um, you know, but just finding, and honestly, it's like multiple choice because there's different things to try. However, it's not very much to compute to see if it forces the whole thing to true just by sticking a 1 in for A and B. If this expression, if A and B is true, then it's kind of like the same thing as setting A and B to true, or just this whole thing to 1 and 1. And then that becomes C or not C, which definitely is 1. Oh, worked great, right? Okay, so that's just an option right there. Or we could, and so here, basically, here's just some rules of thumb for what to look for. All right, so let's take a look at an example then. Let's start with this Boolean algebraic expression. This is in disjunctive normal form. I'm gonna try to find a smaller expression. It's not just guesswork, it says use strategy. So let's find a sub-expression first of length 1 that occurs more than once. Okay, so like A occurs more than once, and B occurs a couple times too. Okay, so I'm seeing that. Also, oh yeah, not C, uh, not C right there, occurs twice. So, all right, all right. So this one, not C. We let that be an expression of length 1. Okay, so we're not letting the not add any length. Okay, so so we have these choices, not C or A or B. Let's choose A and see what happens. When we set A equal 1, then the expression will look like this when A is equal to 1. All right. When A is 1, you say 1 intersects, like everything intersects with something, it's just that thing. So it's just kind of A goes away. So if that's, so now looking at this, we try to see if there's something else we can set to 1 that might make the whole thing go to 1. And then we'd have, you know, something and something else would be like your expression that would be going to 1. So let's try B or not C. Oh, well, why don't we try B? So let's let B be equal to 1. And if B is equal to 1, then we end up getting something like this. All right. Now at this point, there's different things that you could do. You could see that not C can actually factor out, if you think about distributive property, factor out of these two guys. And this is 1. So this really looks like C or not C, which is just 1 itself. So it really does force it to 1 if you let A and B both be true. So A and B is like an expression that would force the whole thing to be true. We just found one that this expression is sandwiched between. It's sandwiched between true and A and B is kind of what we've been able to do. I mean, and I give an alternate description of how you might be able to think through that. You can do a little sandwich swallowing on this expression itself to actually figure out that it's supposed to be 1 as well. And I go through a little description of that. But But nonetheless, okay, so we found out that A and B is a set is the A and B is a sandwich is a swallower. So let's look at the initial expression. So A and B will swallow one of these terms. Which term does it swallow? It actually swallows this guy right here because um, this guy is a subset of A and B, and you're unioning on. So A and B will be the survivor. So you've simplified the expression, so it just says A and B there instead. So kind of what we've just done is we've said we can eliminate that C there is what we've basically done. So we can have an A and B. Now we can keep going. We've exhausted all the things that can occur twice. That occur twice. Okay. Let's see. Because if we set not, okay, we've nearly exhausted. Okay, let's just see what happens when we set this not C equals 1. It requires, oh, I see. Okay, so I kind of talked about what we could kind of do here with that. If we set that equal to 1, then we would require and B, okay, to be equal. So in order to make this whole expression 1, we actually it doesn't work unless A and B are 1. So that doesn't really help us at all anymore here. So I guess we can't work with that one. So let's go to the other sub-expressions that here that we can use, such as D and not D, that occur only once. If we set each one of those to 1, it doesn't really lead to anything. And sub-expression just C doesn't really lead to everything. So what you do is you start with one letter at a time, you set it equal to something, then you see kind of what you need to do from there. So it would go from 1. So you kind of work that way in. And if, and you trying different possibilities for different, and is there anything to add on to it that would make it work or not work? And you can actually work through the important possibilities fairly quickly that way to be able to see if something works or not, or as a swallower or not. Therefore, what we've just shown kind of using that strategy is this is the disjunctive form, as simple as it could probably, as we can get it. That's disjunctive normal form. Now, to get it, the same expression into simplified conjunctive normal form, we just use distributive property, and we would end up at this. Okay, that's just obtained by distributive property. Didn't work right out the details, but distributive property on the disjunctive normal form. Okay, now let's look at this one, this example right here, and see what we can. And this is another example kind of that works through a similar idea. And you can read through this and make sure and see if it makes sense to you. Here's another one. This one is conjunctive normal form, so I'll take a look at that one. It has to do with setting things equal to 0. So the variable A is the only one that repeats. All right, so maybe that's a good one. Let A be 0, and you end up getting this, and setting not B equaling 0 actually force the whole expression to 0 right now, which means that not B is actually, oh, you could actually do a little sandwich following this. So not B can be added onto here, but not B is a subset of that, so it can replace that, but not B and B would be 0. Means the whole, so yeah. So basically, this expression right here is actually 0 right now, automatically already. So is what that shows. So that means that if you set setting A to 0 makes the whole thing to 0. So this expression is in between 0 and A. All right. So okay. All right. So then we can and A on. Let's see what happens when we and A on. So these are, so A is a subset of that and that. So it swallows it in the expression. So you end up just getting this. That's a lot simpler. In fact, that's the conjunctive normal. That's simplified conjunctive normal form, as simple as it can be. And then we can translate that via distributive property into the other one. Example 7, here's another example, and I'll let you read through that particular example, and we'll end this little video here. Thank you so much for watching.